Hello, Math 2 students. Welcome to the Practice Benchmark Chapter 11. I'm just going to go through some of these problems with you, or all of them, to give you an idea how to work these. So let's start with the first one. What is the degree of the monomial? So looking at this monomial, you have an exponent of 7 and an exponent of 2. Now the degree of the monomial is the sum of the exponents. So we have a 7 and a 2, add those together, and your degree is going to be 9. And there you have it. Now, when you have a monomial in one variable, your degree is just the degree of the exponent. If you have a monomial in 2 or more variables, you need to add the exponents to get the degree. Polynomials, remember the degree of the polynomial is just the degree of the largest monomial, or the exponents of the largest monomial. Okay, so this degree would be 9. This degree here would be 8. So let's go on to number 2. What is the sum or difference? We have 6y to the 8th plus y to the 8th. Now these are the same term. You have to have like terms in order to add. They have to be exactly alike. You can't add y to the 8th and y to the 7th. Those are not alike. They have to be exactly alike to add or subtract. So we have 6y to the 8th plus 1y to the 8th are going to give me 7y to the 8th, or y to the 8ths. All right, on to the next one. All right, number 3. A local deli kept track of the sandwiches it sold for 3 months. The polynomials below model the number of sandwiches sold, where S represents days. So ham and cheese, here's the polynomial. Pastrami, here's the polynomial. We need to write a polynomial that models the total number of these sandwiches that were sold. So we're going to just add these together, the ham and cheese and the pastrami. It's represented by S days. So if I add these together, I can find a polynomial that models the total number of sandwiches that were sold. So when I add, I need to only add like terms. Now a great way to do that is to take one polynomial and write it in decreasing order. This is a polynomial in one variable, so I'm going to write it in decreasing order. The third power, the second power, the first power, and then no power. And then here I have the second power, the first power, and then that would be s to the 0. All right, so it's easy to line these up, and these are almost lined up like it is, so I'm not going to rewrite it. I'm going to line up the s squared, and then the s's, and then the constant. And I'm just going to add straight down like that. So it's kind of on the diagonal, but it works. So if I add these two together, I'm going to go, let's see, what's 250 and 180? 250 and 180 is going to give me 430. So my pen is not working. I'm using my mouse, and it's hard to work. All right, now we have 33 s's and 32 s's. Add those together. 33 and 32 s's is going to give me 65 s's. Now that's a 5 and that's an s. I know that's hard to see. We have negative 28s squared minus 7.4s squared. So since they're both negative, I'm going to add them. Negative 28 plus 7.4. Negative 7.4 is going to give me negative 35.4s squared. 35.4 s squared. And then if I add this down, there's nothing to add to it. It's just 4s cubed. All right, and that will be your answer, and that is really hard to read, so I'm going to write it down here. So 4s cubed minus 35.4, and this is supposed to be an s squared. That's what that says, s squared, plus 65s plus 430. Make sure you only add or subtract like terms, all right? Let's go on to number 4, simplify this product. Now this is just distributive property, but now we're dealing with polynomials. So we just have a little more to think about. We're going to distribute to each term. So 2k times negative 3k cubed. When I'm multiplying, I'm going to multiply out the constants. That's going to give me negative 6. And then k times k cubed. These are the same base. I add their exponents. K to the first plus k cubed, that's going to give me k to the fourth. So negative 6k to the fourth, and then 2k times k squared will give me plus 2. Same base, add exponents. K to the first and k squared will give me k cubed. And then 2k times negative 10 will give me negative 20k. And there you have it. That is simplified, and you're done with that one. All right, on to number 5. Find the greatest common factor, or the GCF, of the terms of the polynomial. The greatest common factor is the biggest factor that divides evenly into each of these terms, okay? The variables are easiest to work with. If you look at the variables, what's the biggest variable that divides evenly into each of these? Well, it's going to be the one with the smallest exponent, because x cubed is the smallest exponent. So the biggest thing I could pull out of here would be itself. I can't go bigger because there's nothing more. So it's going to be the one with the smallest exponent. I can pull x cubed out of here and out of here. And x cubed is the biggest thing I can pull out of here because it's itself. Now the constants are a little harder. Some of the work that we do with constants is we factor down into its primes, and then we pull out all of the common primes, and then we write what's left. That's one way to do it. Or you can just do it intuitively and think, what is the biggest number that divides into 20, 44, and 30? So if you think these are both even, so I know 2 goes into all of them. If 2 goes into 30, it would leave me with 15. 2 goes into 44, it would leave me with 22. 2 goes into 20, it would leave me with 10. Well, look at each of these numbers. Is there anything else that divides evenly into those numbers? Let's see. Well, 15 and 10, a 5 would go into those, but 5 doesn't go into 22. No. 3 goes into 15, but 3 doesn't go into 10 or 22. Let's see. 5 goes into 10. We talked about that. 2 goes into 10 and 22, but 2 doesn't go into 15. I can't think of any other numbers. These 3 don't have any other numbers in common, only a 2. 2 is the biggest thing I could pull out of each of these. So 2 is the biggest number, or the greatest common factor. It's the biggest thing that each of these have in common. I can pull out a 2 and an x cubed. There's a 2x cubed in this term I can divide out, a 2x cubed in this term I can divide out, and a 2x cubed in this term I can divide out. And that is your greatest common factor. All right, on to number 6. Let's see, clear that. Number 6, factor the polynomial. 30w to the 6th plus 18w to the 4th. Now to factor it, we do what we just did with that last one. We pull out the greatest common factor. What's the biggest thing that divides into each of these? Let's go with the variables first. That's the easiest. Now the biggest variable that pulls out of w to the 6th and w to the 4th, the biggest variable that I can pull out is w to the 4th. It's going to be the smallest exponent, because when I pull it out of here, I'm left with just 1. So that's the biggest thing I could pull out. I could pull w to the 4th out of here also and leave me with w squared. All right, now let's look at 30 and 18. What is their greatest common factor? Well, I know they're both even, so I know I could pull out a 2. Let's pull a 2 out of those. It leaves me with 15 if I pull a 2 out of the 30, and if I pull 2 out of 18, it leaves me with 9. So I know I can pull a 2 out. All right, can I pull anything else out? Well, 15 and 9, do they have anything in common? Actually, they do. 3, they have 3 in common. So I could pull a 2 out and a 3 out. If I pull a 3 out of here, it leaves me with 5. I already pulled a 2 out. Let's pull a 3 out of there. If I pull a 3 out of 9, or divide the 3 out, it leaves me with 3. All right, do 5 and 3 have anything in common? No. So 2 times 3 is 6. 2 times 3 is 6. So really the biggest number that 18 and 30 have in common is 6. I can pull a 6 out of that. And then what it leaves me with is 6w to the 4th. If I divide 6w to the 4th out of this term, let's first go with the 6. If I divide 6 out of 30, it leaves me with 5. If I divide w to the 4th out of w to the 6, you can write it up here if you like. You're dividing out w to the 4th. You can think of the rule same base, subtract exponents, or 4 w's go into 6 w's and leave you with 2 w's. Okay, so this will leave me with 2 w's plus, and then pull a 6 out of 18. When I pull a 6 out of 18, 18 divided by 6 leaves me with 3. And then when I pull w to the 4th out, w to the 4th divided by w to the 4th is just 1. And 1 times 3 is 3. I don't need to write it. So here is my factored form. I factored out the greatest common factor. All right. Looking at this, does this factor anymore? No, that doesn't factor anymore. All right, let's look at number 7. Simplify the product using the distributive property. Okay, instead of using FOIL, use the distributive property. I like FOIL. I don't care if you use FOIL on this because that's basically what the distributive property has you do. You do your first terms, you do your outer terms, you do your inner terms, and you do your last terms. That is the distributive property. Because what distributive property means is I have to multiply this by this and this. I have to multiply this by this and this. So what it ends up being is first terms. Sorry, I did that wrong. First terms, then your outer terms, then your inner terms, and then your 2 last terms. Okay, so let's do it. Your first term. So here's my first terms. This times this, 2h times 3h. That's going to give me 6h squared. And I'm sorry for the writing. It's going to be very poor. I don't have my pen. And then this times this, that's my outers. 2h times negative 3, it's going to be negative 6h. Then my inners, 4 times 3h, that will be plus 12h. And then my last terms, these two are my last terms. 4 times negative 3 gives me negative 12. Now I always add my 2 middle terms, not always, but usually you get to add your 2 middle terms because they are common. Okay, h squared, they are not common terms with h, but this is an h and this is an h. These are like terms. I can add them. Negative 6h plus 12h is going to give me 6 h's. So my final answer will be 6h squared plus 6h minus 12. And you're finished. All right, moving down. Here we go. Hold on, let's scroll down, pause. Okay, once again, simplify using FOIL. This, once again, is the same as distributive property. This times this and this, so this will be your first terms, your outer terms. And then this times this and this. This will be your inner terms and your last terms. The same as distributive property. Okay, so let's do it. First terms, 5x times 5x is 25x squared. Then your outer terms, 5x times 5 will be plus 25x. Then your inner terms, 3 times 5x will be 15x. And then your last terms, 3 times 5 will be 15. You add your middle 2 terms because they are like terms. 25x's and 15x's, well, 25 and 10 is 35, so that's 40x's. So my final answer will be 25x squared plus 40x's plus 15. And you're finished. All right, number 9's a little trickier because you have a binomial and then a trinomial. You can't FOIL a binomial and a trinomial because you don't have 2 binomials. So what you have to do is distributive. You have to take your first term and multiply it by every term, and then your second term and multiply it by every term. All right, so let's do it. 4k times 2k squared is going to give me 8. And then k times k squared will be k cubed. And then 4k times negative 5k is going to give me negative 20. And then k and k will give me k squared. And then 4k times negative 2 will give me negative 8k. Right? So that was the 4k multiplying by everything. Now let's do 5 and multiply it by everything. So 5 times 2k squared will give me plus 10k squared. 5 times negative 5k will give me negative 25k. I don't know why the k is up so high, sorry. And then 5 times negative 2 will give me negative 10. Now I've multiplied everything out. Now I need to just combine my like terms. I have a k cubed, but I don't have any other k cubes. So I'm going to write 8k cubed up here. That's my only k cubed. Done with that one. I have negative 20, I have a k squared here and a k squared here. These are like terms. Negative 20k squares and 10k squares make negative 10k squared. That's how I like to think of it. They're both k squares, so you got to combine them. Okay, we did those. Now we have negative 8k's and negative 25k's. So the k's are like terms, so I'm going to add these together because they're both negative, and I'm going to make it negative 33k. Done with those, and then I'm left with just a negative 10. It's a constant, and that will be my final answer. All right, let's move on to number 10. What's a simpler form of each product? So this is an expansion. Now, the most common mistake I will see with this one is you guys will go like this. Oh, it's squared. Distribute the 2 to both terms, and you'll write something like this. 9m squared, and then you'll do this, and you'll write plus 64. No, don't do that. Don't square both terms like that. That rule only works if everything is multiplied together and then you square it. Then you would square the 3, the m, and the 8, okay? Because everything's multiplied together. Everything's getting squared. These are added. They're not multiplied. Do not do this. You're going to miss your middle term. What this actually means is, this means 3m plus 8 times 3m plus 8. All right, so you're going to have to FOIL this. 3m times 3m is 9m squared. And then the outer terms, you're going to get 8 times 3, 24m. Then the inner terms, 8 times 3 plus 24m. And then you're going to get 8 times 8, which is 64. Now, if you know the quick way, because this is a square, you know this middle term is going to be 2 times the first times the last. You can do that, but if not, just FOIL it out. 24m plus 24m is 48m. So you're going to get 9m squared plus 48m plus 64. And that will be the final answer. So don't give me the 9m squared plus 64 and forget your middle term. Do not do that. You have to FOIL it out, or you have to know the rule for it's the first term squared plus 2 times the first times the last plus the last term squared. All right, let's go on to number 11. What's a simpler form of this expression? Once again, if you look here, this is the difference of 2. You're going to have, these are conjugates. You're going to have a 4d plus 6 and a 4d minus 6. Let's FOIL it and see what happens. Multiply the first terms, you're going to get 16d squared. Outer is going to give you negative 24d. Your inner term is going to give you positive 24d. And then your last terms, negative 6 and multiplied by positive 6 is going to give you negative 36. So when I FOIL this out, I'm going to get the difference of perfect squares. 16d squared, well, the negative 24d and the positive 24d cancel out. So I'm just going to be left with 16d squared minus 36. The difference of perfect squares looks like this. The same term with the plus, and then the same term with the minus, or the same polynomial. Okay, let's go on to number 12. Number 12, what's the factored form of the following expression? So we're just going to do some factoring. We did some multiplying. We did all that FOILing. Now basically we're going to unfoil, all right? Now, when you don't have a term or a constant in front of your first squared term, this is the easiest way to factor, okay? We know we want to put it into something like this. And there are different methods. You can use the X method. If you learned this on YouTube or whatever, use this method. Or there's the box method, okay? You can use this method. You can guess and check, okay? Guess and check means, you know, the multiples of d squared go here and here. The multiples of 12 go here and here. So, d squared, my only choices are d and d. That's easy. The multiples of 12, well, what are the factors of 12? that add up to be negative 7. Well, the factors of 12, I have the choice of 1 and 12. I know those aren't going to add up to be negative 7. 2 and 6, those aren't going to add up to be negative 7. 3 and 4, that might work, but these are positive and I need a negative 7. Another thing that multiplies to be negative 7 would be negative 3 and negative 4. Those are going to add to be negative 7. So these are the factors I choose. So the factors I put here are negative 3 and negative 4. Now here's how I check it. Your first terms better multiply to make that first term here. Your last terms better multiply together to make that last term. And your inner, negative 3d, and your outer, negative 4d, better add together to make negative 7d, which is your middle term. Okay? So your inner term and your outer term better add to be that middle term. And that's how you do that one. On to the next one. D squared minus 9d plus 14. Once again, same process. Okay, you know your first term, you're going to factor it down. This times this makes your first term. So you go a d and a d. Your last term, the factors of it go here. So we need to figure out the factors of 14 that will add up to be negative 9. All right. Well, 14 is going to be 7 and 2 or 1 and 14. Now, 7 and 2 are going to make 9, but I have a negative 9. So I also know negative 7 and negative 2 multiply together to make positive 14, but those add together to give me negative 9. So that will be my choice of factors, these guys. So I'm going to do negative 7 and negative 2. Check it. D times D does give me D squared. Negative 7 and this, sorry, that's a 2. Looks like another 7. Negative 7 and negative 2 do make positive 14. Now check your inner term. So negative 7d and your outer term, negative 2d. And do those add together to be your middle term? Well, negative 7d and negative 2d make negative 9d, so it works. There's my answer. It will be d minus 7 times d minus 2. All right, on to number 14. The area of a rectangle garden is given by this trinomial. What are the possible dimensions of the rectangle? So let's look. We have a rectangle, and it's a garden. We know it's length times width. Length times width is my area. So if they tell me my area is x squared plus 6x minus 40, I have to figure out what were my lengths and widths. So what two things did I multiply together to give me that area? Okay, so I'm just going to factor. If I factor, I can figure out those two things that I multiplied together to give me this. I'm unfoiling it. So this term, the first term goes here and here. The factors of the last term, negative 40, go here and here. Now I have to figure out which ones I'm going to pick because negative 40 has more than one choice. And I want them to add to be 6, positive 6. So negative 40. I know I have 1 and 40. That's not going to be it. I know that's not going to make 6. 4 and 10. That's a possibility. 4 and 10 could be combined to make 6 depending on how I work it. How about, hold on, let's move this over. How about, what else makes 40? You could go 8 and 5. 8 and 5 aren't going to add up to make 6 though. 2 and 20 aren't going to add up to make 6. So I'm going to go with 4 and 10. That's going to be our best choice. But I need this to be negative and that to be positive. So I'm going to go, which one of these am I going to make negative? I'm going to make the 4 negative because it's smaller. Negative 4 times 10 is negative 40. Negative 4 plus 10 is positive 6. So there are my factors and I've got it. Negative 4, positive 10. So my length could be this and my width could be this, depending on how you do it, or length and width. But those are my dimensions. All right, what's the factored form of the following expression? We got to factor this. Okay, now this gets a little nitty-gritty. I now have a constant here on these ones. So factoring these are a little harder. Now, the text has you go through a process where what you do with the text is, let's just write this out first. I like to use the guess and check method with these because sometimes writing it out takes quite a while. So I know this first term goes here and here, and the last term goes here and here. So what I need to know, because I don't just have an x and an x like I did before, I have this term 40. So I need to know the factors of 40 that will be able to fit here. So I know I'm going to have 1 and 40. I could have 2 and 20. I could have, let's see, 5 and 8. What else makes 40? All right, let's go with these for now. Now I need to know the factors of 56 that I could possibly put here and here. Okay, so 56 could be 7 and 8. 56 is divisible by 2. I could have 2, that's an 8. I could have 2 and 28. Let's see, what else makes 56? 4 and 14. Okay, so all of these choices could be the ones I put for here, and all of these choices could be the ones I put for here. But I need my choices to be the inner term and the outer term have to add up to be that middle term, 99x. Okay, that's my goal. So that's what I'm searching for. I need it to be 99x. How can I make that work? Well, 99x is kind of a big number. So you can go about guessing and checking. I can go, all right, let's try 2 here. Let's try these terms, 2 and 20. Let's try 2 and 20, okay? And I didn't give myself much room there. Let's erase that and fix it. Okay. Let's do 20x and 2x. So those will be my first terms. And then we'll worry about the positive and negatives in a minute. Let's pick some terms over here. Let's try 7 and 8. Okay, now I'm going to do my inner terms. Well, 7 times 20 is going to be 140. That's pretty big. And then 2 times 8 is going to be 16. Well, 140 and 16 aren't going to give me 99. So not those. Let's not pick those. All right. Let's try again. We could try, hold up. Okay, let's erase that first one and let's try again. So 2 and 20 didn't work with 7 and 8. Let's go ahead and try 5 and 8. Let's try 5x and 8x. All right, let's try those guys. And we're trying to get to 99x. So let's try 7 and 8. They seem reasonable. Let's see what happens. All right, so I know 7 times 8 is 56. So this would be 56x. And then 5 times 8 is 40. Do 56 and 40 make 99? No. However, let's undo that. Let's try this. I need it to be a little bit bigger. So I did 7 and 8. Let's try 8 and 7. Well, 8 times 8 is 64. And then 7 times 5 is 35. And 64 and 35, well, 5 and 4 is 9, and 6 and 3 is 9. I've done it, okay? Now, I want a positive 99x and a positive 56. Well, that's easy. That means positive, positive. So that's how I guess and checked this one. All right, 5x plus 8, 8x plus 7. That is your solution. Now let's say I wanted to do it how the book does it. That's fine. This is how the book is going to do this one. Okay, you're going to end up with the same solution. And the book's going to do it like this. They're going to say, okay, you need to figure out, because you're going to work this, Okay, so this term goes here and here, and this term goes here and here, just like we did before. But because we have this constant here, we have to multiply these two together. So we have to multiply 40 and 56, and it's going to be a huge number, 2240. Okay, and what we need to do is figure out the factors of 2240 that sum to be 99. Okay, so we want the factors of 2240 that add to be 99. Now the book writes it that way. I like to write it in like I did before, like this. The factors of 2240 that add to be sum to be 99. Okay, just like I did with these, I did what are the factors of 14 that add to be -9. Okay, but this is a little trickier. You have to multiply these together first. Okay, because I have this term, this is trickier. All right, well, what are the factors of 2240? Oh my goodness, there are a lot of factors of 2240. So I already know based on what I did here, this was 64 and 35. 64 times 35 gives you 2240. Now, how did I know that? Because I just did the guess and check method. That is why I like the guess and check method, because I only had to write the factors of 40 over here and the factors of 56. I didn't have to multiply them together and write the factors of 2240. There's a lot of factors. There's a lot of possible factors, okay? So write out all the possible factors, figure out which ones add to be 99. This is a huge number. Guess and check works better for me, okay? Well, I figured out, let's say I figured out, I wrote out all the factors of 2240. I mean, I could go 2240, what's it divisible by? Is it divisible by 20? It is. It's 20 and 112. Though that's another factor. I mean, there's so many factors of this, but I know those don't add to be 99. These do, okay? So once I figure out those factors, I multiply these together, I write it here. And once I figure out the factors that add to be 99, those are my factors that break up my middle term. So this is how the book asks you to do it. So you write this, 40x squared plus, you break up your middle term and you write it as 64x plus 35x. Okay, and then you write your last term, plus 56. So this is the same as this trinomial. I've just broken up 99 into two factors. Then what you do is you factor by grouping. You group this first group together and the second group together. You pull out the greatest common factor in this first group. Well, what's the biggest number that divides into 40 and 64? Well, I know 8 goes into 64 and 8 goes into 40. Let's try that. They both have an x in common, so I pull out their x, and I'm left with x here. And then if I divide 8 out of 40, it leaves me with 5. And then here, if I divide 8 out of 64, it leaves me with 8. And if I divide x out, it leaves me with just 8. All right. Now let's go over to here. What do these two have in common? Well, let's see. I know 7 goes into 35 and 7 goes into 56 evenly, so I can pull out a 7. So if I pull a 7 out of 35, I'm left with, let's see, 5. I'm left with 5. And if I pull 7 out of 56, I'm left with 8. Okay, so now I can see I have a 5x plus 8 and a 5x plus 8. These two have something in common. I have this times 5x plus 8, this times 5x plus 8. So I factor out the 5x plus 8. And when I pull 5x plus 8 out, I'm left with 8x plus 7. And that's what's left. So you can see this gives me the same answer as I did when I just guessed and checked. This is why I prefer the guess and check. I think it's easier, especially when the numbers are big. All right. Okay, on to number 16. Let's do this guy. Let's try him with the guess and check. Now this one would be easier to do the other method because the numbers are smaller, but let's just show you how this would work. Okay, so your first term is here and here. And I know I'm going to have a D and a D. I just have to figure out the factors of 12. Well, the factors of 12 are 1 and 12. You could do 2 and 6. That's a 12. Or you could do a 3 and a 4. Okay, so those are my choices to go here. Now, the great thing about -1, that's awesome. What are the factors of -1? Well, -1 and 1. That's your only choice. So you can put a -1 here and a 1 here, or you could flip them around depending on what you need. Now we need 4D to be our middle term. So remember, we want our inner term and our outer term to add up to be 4D. So that's going to help us choose which of these factors to pick for here and here. So let's look. I want a 4, so which one of these is going to help me get a 4D? If I multiply by these terms, well, probably the 2 and the 6. So let's try. Guess and check. I'm going to put a 2 here and a 6 here. Now check your inner term and your outer term and see if it adds to be 4D. Well, -1 and 6 gives me -6D. And then 2 and 1 gives me 2D. Well, -6D and 2D give me -4D, but I want positive 4D. So I can either switch these around, or I could switch this around, make this positive and that negative. If this is positive and this is negative, it still gives me -1. All right, so +1 times 6 gives me positive 6D, and then 2 times -1 gives me -2D. Positive 6D minus 2D does give me 4D, and I've done it. These are my factors. Guess and check. Now do it the book method. The book method would say, take 12 and -1, multiply them together, you get -12. And then it would say, what are the factors of -12? Multiply these two together. What are the factors of those that add up to be 4? That sum to be 4. So you would have gone 1 and 12, 2 and 6, 3 and 4. And you would say, factors of -12, well, one of these have to be negative to make that negative, whichever one. It could be the other one. We want positive 4 though. So it's going to be these two, so it's actually going to be +2, -6. No, it's not. I was just kidding. It's going to be -2, +6. I don't know why I did that. Sorry. All right. Those are going to give me 4. So there's my factors. And then what they have you do is go, all right, well, then I go 12D squared, and I break up 4D into -2 and 6. -2D plus 6D. And then I'm going to erase all this because it's in my way. And then I'm going to get -2D plus 6D and then -1. So I basically just broke up 4D into those two terms, which are the two terms that worked here in my guess and check, just so you know. They end up being the same terms, right? Then the book has you group like this and like this. So you pull out the greatest common factor of 12D squared and -2D, and the greatest common factor would be 2D. Okay, divide 2D out of here, you're going to be left with 6Ds. Divide 2D out of here, you're going to be left with -1. Okay, and then 16 minus 1, what do these have in common? Nothing. So their greatest common factor is just 1. They don't have anything in common. You can pull out a 1 and that's it. Okay, and you'll be left with 6D minus 1. Okay. Now what are these two? This is multiplied by 6D minus 1. 1 is multiplied by 6D minus 1. Pull out a 6D minus 1. So I pull out 6D minus 1. And I am left with 2D plus 1. Yeah, that's an ugly D. 2D plus 1. And look, it's exactly what I have here. 2D plus 1 times 6D minus 1. 2D plus 1 times 6D minus 1. So this is the book method. Guess and check is my choice. That is how I think it's easier to just guess and check. All right, let's go ahead and scroll down. Number 17. We got to factor this guy, and I like him because he does not have a constant in front, right? So this is going to be easier. Let's write it over here. So I know it's just D and D. I don't have to worry about the factors of this because there aren't any. It's just D and D, okay, or 1 times 1. And then I need to know the factors of 36, okay? What are the factors of 36? 1 and 36. We could go 6 and 6. We could go, actually, I'm probably going to stop there because I want the factors of 36 that add to be 12, my middle term. Okay, this is more straightforward. You don't have to break this up into anything when you're doing it this way, all right? 1 and 36 aren't going to add to be 12, but 6 and 6 are. Those add to be 12. It's positive. That's positive. I found my factors. It's plus 6, plus 6. Check your middle terms. Your inner term is 60, and then this outer terms, the outer terms are 60. Make sure those add together to be that middle term, 12D. And 60 and 60 make 12D, so this is correct. Ding, 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 I'm done. All right, on to number 18. Okay, we're going to hit the factoring hard again. We got to find the area of a square lawn. What's the length of one side of the lawn? Now, if you know it's square, that should be your key to knowing the length and the width are the same, okay? Length and the width are the same. Now, this times this is going to be this because it's the area. Two things multiply together to give the area, length and width. Now we can find the dimensions. If you know they're the same, we'll check to see if this is a perfect square trinomial. Is this a perfect square? 25x squared? Yep, it's 5x squared. Is this a perfect square? Yep, it's 3 squared. Is your middle term 2 times the first term, 5x, times the last term, 3? Well, let's see. 2 times 5x times 3 is 30x. It is. This is a perfect square trinomial. Now, if you can't remember how to factor perfect square trinomials, you can just do the regular old factoring. These guess and check. This term goes here and here, so I'm going to pick 5x and 5x. The factors of 25 are 5 and 5, right? Factors of 25, they're 5 times 5 or 1 and 25. Those are our only choices, okay? And what are the factors of 9? And the factors of 9 are 3 and 3 or 1 and 9, okay? So I'm going to pick the 5x, 5x, and I'm going to pick the 3 and 3. Positive, 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 check. Does the inner term, 3 times 5 is 15x, and the outer term, 3 times 5x is 15x. Do they add up 30x to be that middle term? Yes. So bam. 5x plus 3 times 5x plus 3. What is the length of one side of the lawn? Well, since it's a square, they're the same length. It's 5x plus 3. All right, and there's your answer. Let's go on to number 19. Let's see, what's the factored form of the following expressions? Now we're getting into special things. We've got the difference of perfect squares here. Check it. Anytime you see two terms, you should think difference of perfect squares. Think that anytime you see two terms, okay? Check and see if that's a minus sign. If that's a plus sign, I'm stuck. It's a minus sign, so I have the difference of two perfect squares. That's a perfect square, that's a perfect square. It is 8 squared. So if you prefer to write that square out, it's 8 squared. Difference of perfect squares looks like this. S minus 8 and S plus 8. Now remember, the reason why when you multiply this out you don't get a trinomial is because with difference of perfect squares, the inner term, negative 8s, and the outer term, 8s, they add together. Negative 8s and positive 8s is 0. That's why there's no middle term, okay? So one's positive, one's negative. Oh, sorry, here's your answer. There's your factored form. All right, on to this one. You have two terms, so I'm thinking difference of perfect squares. Now this one is tricky. These numbers are big. Before you do anything, you should always look for a greatest common factor. Do 225 and 144 have anything in common? Well, I know 225 is 15 squared. So this will be 15x squared, and 144 is 12 squared, all right? So I can do the difference of perfect squares here, but I want to go most factored. So this is what I'm going to see from a lot of you with something like this. You're going to go the difference of perfect squares, 15x minus 12, and then 15x plus 12, okay? Yes, that is a factored form of this, but it's not most factored. 15 and 12 have something in common. They're both divisible by 3. I can pull a 3 out of here, and I can pull a 3 out of here. Now, these are all multiplied together, so pull both 3's out to the front. 3 times 3 is 9, and it's actually 9, okay? When I pull a 3 out of here, it leaves you with, I'm going to write it down here. When I pull a 3 out of here, okay, it leaves you with 5x minus 4. So I factored it, I divided a 3 out of 15, it left me with 5. I divided a 3 out of 12, it left me with 4. When I divide a 3 out of here, same thing. Leaves you with 5x plus 4. Okay. I divide a 3 out of here, it leaves me with 5. I divide a 3 out of here, it leaves me with 4. So when I multiply those together, it leaves me with 9 times 5x minus 4 times 5x plus 4. This is the most correct answer. This is the answer that most of you will give me if you're not careful. Okay, be careful because yes, that is the difference of two perfect squares of these. But I can go back and look at this and go 225 and 144. Those are both divisible by 9. So before I break it into the difference of squares, divide 9 out. 225 divided by 9 is 25. So I'm going to start here. Let me show you another way to do it. Start here and go, all right, well 9 is divisible into both of those. Pull that out first before I start doing anything. Okay. 225, if I divide out 9, it leaves me with 25. 25 times 9 is 225. So 25x squared. And if I divide 9 out of 144, I get 16. So this is going to be 25x squared minus 16. Okay. Pull a 9 out of both of those. They have a common factor. I pulled it out and left me with 25 minus 16. Now that's the difference of perfect squares. This is 5x squared. So I'm going to go ahead and do the difference of squares. 5x squared, and then this is 4 squared. So it factors like this. 5x minus 4 and 5x plus 4. Bring down the 9, and that is the easier way to do it. You get the same answer. Okay, so factor out your greatest common factor first. I know a lot of you are going to look at this and go 15x minus 12, 15x plus 12. That looks done. But careful, 15 and 12 have a common factor of 3. It's not most done. Make it most done. All the way. It's sort of done. It's not most done. All right, let's go into 21. 21, factor this expression. All right, whenever you see 4, so you have 4 terms, you should automatically go 4 terms, factor by grouping. So you're probably going to factor by grouping when you have 4 terms. It should ding, ding, ding in your head. Just like when you use the Book's method to factor those trinomials with a term in front, you use grouping. This is 4 terms. You're going to factor by grouping. Now, before you start your grouping, see if there's a greatest common factor you can divide out first. That's the first thing you want to do. All right, there's a W, a W, a W. That one doesn't have a W. So I can't pull out W's because that one doesn't have one. 8 and 12, they have a 2 in common. They have a 4 in common. 10 doesn't have a 4, but it has a 2 in common. 15 doesn't have a 2 in common. So nothing in common. I'm good. Factor by grouping. Group these 2 and these 2. When I group these 2, what's their greatest factor in common? Well, a W cubed and a W squared. The smallest exponent, remember, the W squared is what divides out of both of these evenly. Now look at the constant, 8 and 12. What's the biggest term that goes into 8 and 12? Let's see. 4 goes into 8, 4 goes into 12. I believe that's the biggest term. Pull the 4 out. When I do that, I pull the 4 out of here, so I divide 4 out of 8, and it leaves me with 2. Divide W squared out of here, and it leaves me with a W. Okay, here, divide a 4 out of here, it leaves me with 3. And I divided a W squared out. Well, W squared divided by W squared, I pulled that out already. So when I divide 4W squared out of 8W cubed, it leaves me with 2W. When I divide 4W squared out of 12W squared, it leaves me with just a 3. Go over here. What do these two have in common? If they have nothing in common, you just pull out a 1. But let's see. 10 and 15 do have something in common. They have 5 in common. They don't have a W in common. I can't pull that out, but I can pull out a 5. So I pull out a positive 5, and it leaves me with, divide a 5 out of there, I get a 2W. Divide a 5 out of there, I get a 3. Now, your goal is that these are the same. So if they're not the same, you did something wrong. Factoring by grouping, that's your goal. Because when these are the same, now these are a common factor, and I can pull them out and leave me with 4W plus 5. So that's what I'm going to do. These have a factor in common, so I pull out 2W plus 3. And what I'm left with is 4W plus 5. 4W squared, sorry, plus 5. All right, there's my factor by grouping. Now the last thing you want to do is just see, can these be factored anymore? If this was like the difference of perfect squares, I could bring that down even more and factor it even more, but it's not. You're done. All right, that was 21. Let's go on to 22, a little more difficult form of this. You've got 4 terms, so think factor by grouping. Now before I do that, I check to see if there's anything I can pull out first. So I got a k cubed, a k squared, a k. That one doesn't have a k. So I can't pull out a k. Look at the constants, 108, 90, 162, 135. All right, is there some term that I can pull out of those? Well, they're not all even, so I know it's not a 2. Well, let's see. What about a 3? Would a 3 pull out of those? I'm just going to go ahead and use my calculator and go, does 108 divide by 3? Oh, it does. Does 90 divide by 3? I know it does because it is a 9 in the first term, so yes. Does 162 divide by 3? Yes, 54. Does 135 divide by 3? Yes, 45. Now I'm looking at all that and thinking, is there a bigger number besides 3? Well, 36, 54, and 45 are all divisible by 3 again. So scratch that. Let's try 9. Does 108 divide by 9? 12. 90 divided by 9 gives me 10. Does 162 divide by 9? Yes, 18. Does 135 divide by 9? Yes, 15. Let's try that and see if there's anything left over I can still pull out. So if I pull out a 9, if I pull a 9 out of 108, 108 divides by 9 and leaves me with 12, 12k cubed. 90, if I pull out a 9, it leaves me with 10k squared. 162, if I divide by 9, it leaves me with 18, and that's k. 135, if I divide by 9, it leaves me with 15. Okay, do these have anything else in common? Well, 12, 10, and 18 are even, so I could pull out a 2, but 15 is not even. I can pull another 3 out of 12, but I can't pull it out of 10. And let's see, I could pull a 5 out of 10, but not out of 12. So I think we're good. That's it. Just pull that 9 out. So that's the hardest part, is factoring out that common factor. Now you've done that, go ahead and do the factoring by grouping. Okay, remember that 9's still there. So I'm going to group these two together, and then I'm going to group these two together. And I'm running out of room, so I'm going to write it up here. All right, so let's erase this. And my eraser's going. Okay, so, ooh, I erased that too by accident. Okay, so these two, the greatest common factor of 12 and 10. Let's see. They're both divisible by 2, and they both have a k squared in them. So I'm going to pull out 2k squared. And that leaves me with, divide 2k squared of this, divide 2 out of 12, leaves me with 6. Divide k squared out of k cubed, it leaves me with k. All right, divide 2k squared out of this. Well, if I divide 2 out of 10, it leaves me with 5. And if I divide k squared out of k squared, it leaves me with just nothing. I pulled them out. I divide them out, leaves me with 1. So that is a negative, so 6k minus 5. Come over to these two terms. What do they have in common? Well, 18 and 15, let's see. They have a 3 in common. 3 divides into both of those. They don't have any k's in common, so I'm just going to pull out a 3. Okay, I pull a 3 out of 18k. 18 divided by 3 is 6k's. 6k. That's good. That's what this is. That's what I wanted. Divide 3 out of 15, it leaves me with a negative 5. Yay, that is what I wanted. These are the same. Okay, don't forget, I just did this. That 9 is still there. We can't forget him. He's still out here. Okay. All right, now I pull out my greatest common factor, 6k minus 5, 6k minus 5. Pull him out, and I get 6k minus 5 times, and what's left is 2k squared plus 3, times 2k squared plus 3. All right, and bring down the 9. Now check these and see if they factor anymore. That's not a difference of perfect squares. It doesn't. You're finished. Okay, so this was factoring by grouping. It was like this one, but harder because I pulled out a common factor first. All right, on to the next one. Let's scroll down the mouse, and we got 23. The area of a rectangle parking lot is 21x squared minus 44x plus 15. The width of the parking lot is 3x minus 5. What's the length of the parking lot? All right, they gave us one of them. So that's kind of nice. I got to factor this one, and this is the hard kind of factoring because this is a big number, okay? So looking at this, I'm going to have to figure out, I'm going to do this one by the guess and check method because if I did 21 times 15, I'm going to get a huge factor. I don't want to do that. So I have the area of a parking lot, okay? They told us one of the factors was 3x minus 5. I got to figure out this factor here so that I multiply those together to get this. Okay, so I'm going to factor this. I'm going to go 21x squared minus 44x plus 15. My son is super loud. Hold on, I'm going to pause that. Okay, so if I factor this by the guess and check method, I'm going to come over here and write the factors of 21. What are the possible factors of that? Well, let's see, 7 times 3, 1 and 21. I could write those down. Let's go with 7 and 3 for now, and the reason is because I can see one factor already. Okay. Factors of 15 are going to be 1 and 15 and 3 and 5. Okay. So what goes here will be an x and an x, and now I have to figure out if it's 7 and 3 or 3 and 7. Well, let's try 7 and 3. Now the factors of 15 go here and here. So is it going to be 3 and 5 or is it going to be 5 and 3? Well, look here. 3x minus 5 is one of the factors. So I know it's going to be a 5 right here. Okay, and a 3 here. Now let's look at our positives and negatives. That has to be a negative. That has to be a positive. So when that happens, instead of going positive, positive, I'm probably going to go negative, negative. Because a negative times a negative makes a positive. And I need my middle terms to be negative. Negative times a negative makes a positive. Check your middle terms. Your inner and your outer better add together to be this. 3 times 3x is negative 9x. 7 times negative 5 is negative 35x. Negative 35 plus negative 9 is negative 44. I've done it, here it is, and this helped me to know already with my guess and check method what I was looking for. So what's left? The length of the parking lot has to be 7x minus 3. That's going to be my length because I had my width, and I multiplied those together to get my area. All right, there we have it. Let's go on to 24. 24, a shipping box in the shape of rectangular prism. So now we're looking at a prism. Prism has a volume of this. What expression can represent the possible dimensions of the box? Use factoring to find length, width, and height. We're talking volume here, not area, so be very careful. All right, so if I do volume, let's just kind of draw it like this. And I'm going to do this to try to make a box here. Okay, so we're doing volume. We want length, we want width, and we want height. Okay, so you got 3 dimensions, length, width, and height. We got to factor this. So first thing you want to do, it's a trinomial, and usually we factor to 2 binomials. So how are we going to get that third factor? See if there's a greatest common factor that pulls out. That's what we can do. We've got 3 x's, so we should have 3 factors. So let's look. There's an x in this term, an x in this term, and an x in this term. I can pull out an x. Okay. I have a 12, a 32, and a 20. So is there a constant that can divide out? Well, I know those are all even, so for sure 2 divides out. Is there something bigger? Well, let's see. 12 is divisible by 4. 32 is divisible by 4. 20 is divisible by 4. Let's pull out a 4. All right, if we do that, let's see what's left. If we pull out a 4, 4x, if I divide a 4x out of this, it leaves me with 12 divided by 4 leaves me with 3. If I pull an x cubed and I divide out an x, I'm left with x squared. Divide a 4 out of this, well, 8 times 4 is 32, so it leaves me with 8. Divide an x out of x squared, it leaves me with an x. Divide 4 out of this, 20 divided by 4 is 5. And I pulled the x out, so that leaves me with just a 5. No x's because you pulled it out. So you can check it by multiplying it back and make sure you get back to this. This times this gives me 12x cubed. This times this gives me 32x squared. This times this gives me 20x. I'm good. So there's one of my factors. Now I have a trinomial I factor into two binomials. Now I'm going to use the guess and check method on this because it's small. So two binomials. So I know this term goes here and here. Now I wrote 3x and x right away because what are the factors of 3? 1 and 3. So it's either 3x and 1x or it's 1x and 3x. And I usually like to put the big term first. So I just went ahead and did that. What are the factors of 5? That would go here and here. Well, 5 is 1 and 5 or 5 and 1. So I'm trying to get to 8. Should we try a 5 here and a 1 here? Let's see. Multiply the inner terms, I get 5x. Multiply the outer terms, I get 3x. 5x plus 3x do make 8x's, and I've done it. They're positive because that's positive, so this has to be positive. Multiply those two together, it has to be positive. Add these together, it is positive. So I've done it. So this factors into this, and remember this is the factor on the outside, it's still here. So there is my solution, and let's circle it in red. 4x times 3x plus 5 times x plus 1. Okay, so that would be a length, a width, and a height. So if you did 4x times 3x plus 5, that could be a width, and a height could be x plus 1. All right, it doesn't specify which is which. That says x plus 1. That's really hard to read. Let's try that again. This says x plus 1. And that I'm pointing to the height right there. Okay, so length 4x, width 3x plus 5, height x plus 1, that would work. Or just write all the factors for length, width, and height. Okay, so 3 dimensions on that. All right, last one. Let's hit it. Is the sum of the two polynomials always a polynomial? Explain and give examples. That's a good question. Now, to be a polynomial, there's certain rules. You can't divide by a variable. You can't have a variable in the exponent. Let's see, if I add two polynomials, let's just say 3x squared plus 5x. Well, those aren't like terms, so I'm done. It's still a polynomial. That's a polynomial. That's a polynomial. Let's say they are like terms. If I add them together, I'm going to get 8x squared. Well, that's still a polynomial. So here's the reason on this one. If you think about this, the answer here is yes. Is the sum of two polynomials always a polynomial? The answer is going to be yes, and here's why. Okay, because, let's do a little text here. Yes, and this is why. If you add two polynomials, you can't change the degree. It's x squared and x squared. The constants add together to maybe make it bigger or smaller if you subtract, but the degrees or the exponents don't change because you have to have like terms. So if you add two polynomials, you can't change the degree. You can change the degree when you divide, like when we were factoring things out, we were dividing them out. When you divide, you can, but here we're just adding polynomials. So you can't change the degree. So it seems to me that if you add some polynomials, you're just going to have a bigger polynomial, right? You can't generate new terms either. So if I have x squared, so let me give you another example that you would show me. You would say something like this. Well, if I have, let's say, some fractions, 1/2 x squared plus y to the 5th minus z. Well, these are all polynomials. This is a polynomial. There's multiple variables here. I can't generate new terms even if I added, let's say, 2 x's, or if I added 2x squareds. Well, the 2x squareds and the 1/2 x squareds could be combined to be 2.5 x squareds, but I can't generate new terms. I still have x squareds. I still have y to the fifth. That's a 5. I still have a z. I still have an x. I can't generate new terms. They're all still here. The like ones get to combine into one term, and I can have 2.5 x squareds, but I didn't generate any new terms. I still have x squareds. I still have z's. I still have y to the fifth. I still have 2 x's, okay? So I can't generate new terms to make the polynomial be different. So my solution would be, because I can't generate new terms that are not monomials or polynomials, so the sum must be a polynomial. And that's how I'd work that. And then show me a few examples. Give me like a 3x squared plus 5x squared equals 8x. Give me an example where there's different terms and you add them together like this, and you still get one term, but you didn't generate new terms. So it must still be a polynomial. You're not dividing out anything. You're not square rooting anything. So you're good. All right, guys, that's it. That's how you do this. Have a wonderful day. Let me know if you have any questions. And have a great week.